Good morning, RC1. Our lesson for today is design of two-way slab by coefficient method. So ito ang ating input data. Meron tayong Fy, F'C, and clear cover. Tapos yung mga superimposed loads which is composed of live and the dead loads. Para sa live load, we have 4.8 kPa. And then superimposed dead loads, you have movable partition na 1, floor finish 1.8, ceiling and utilities 0.4, tapos unit weight of concrete. And then tatanungin niya, bottom of bars laid first, yes or no. So normally ang sagot dyan ay yes. So ito yan. Yung longitudinal bars, ito, that means parallel to the longer dimension LB. Tapos yung transverse bars, yan yung bars parallel to the short dimension. Also, transverse bars is perpendicular to the longer dimension. Okay, ang ibig sabihin yan, bottom bars parallel to longitudinal direction laid first. Yes, etong bakal na mahaba, yan ang unang inilalagay sa forma. After that, papatungan ng bakal na transverse. Yan. Ngayon, yung naunang bakal, nasa ilalim yan, syempre. Ang effective depth niyan ay dx, tapos yung nakapatong na bakal, ang effective niyan ay dy. Going back, meron tayong db tsaka dt. dB means diameter of bar, 12 mm, and then dt, diameter of temperature and shrinkage bars, 10 mm. Tapos, thickness na 1 to 5. Yung diameter of bar, yan yung longitudinal and transverse bars. Tapos, dt, yan yung temperature and shrinkage bars. Yan yung nagre-resist ng mga expansion, thermal, so forth and so on, creep, shrinkage, so forth and so on. And yung nagre-resist ng moment, yan yung 12 mm. And then we have beam width, 250 mm, trial width yan. Tapos yung thickness is also trial thickness, of course. And then, ang coefficient method is napalibutan dapat ng beams on all four sides. Yan yung trial beam width na 250 mm or 0.25 meter. And then, ultimate load is 1.2 dead plus 1.6 live. Tapos, mayroon title ng slab or ID. You have sample 1. And then, we have case, which is 4. Ang ibig sabihin naman ng case, ito. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yung case 1, discontinuous on all four sides or walang karugtong na slab. Yung case 2 naman, interior slab, merong karugtong na slab or nakadikit na slab on all four sides. Yung case 3, 2 long sides free. Case 4, corner slab yan. And then case 5, 2 short sides free. Case 6, long side fixed. Case 7, short side fixed. And case 8, long side free. And case 9, short side free. Next, you have center to center short direction, which is 5.5 meters. Ito yun. That is this dimension. Center to center long direction is 6 meters. That is also your LN. Take note, center to center yan. And then, that is your LN. So, start tayo ng solution. Yung mga equations niyan nandito sa ilalim ng lecture. Standard equations for beta and rhomin. And ang-iba lang yung Rhomax. Yung equation ni Rhomax, ito. So that is 3 all over 7. Okay? Mas conservative ang Rhomax ng slab compared sa singly reinforced beam. Okay, sa solution, yan ang mga basic constants. Beta, Rhomax, rhomin, and then rho G. Sa rho G, ang gagamitin natin ay 0.002 dahil ang Fy ay less than 300 megapascal, which is 228. And then, LA, yan naman yung unsupported length. Ito. Okay, so unsupported length or clear span. So, minus siya ng beam width. Sa LB naman, 5.75. So, that is 6 minus 0.25. And then, we will check if the slab is qualified for two-way. Ang basic concept nito, kapag lumampas ka ng dalawang square sa loob ng slab, gagamit ka na ng one-way. So, LB all over LA, that means 1.09 squares, it is less than 2. So, okay siya. Okay? And then, we will check minimum thickness. Ang nilagay nating trial thickness ay 1.25. We will check this. Ang equations niyan, nandito, minimum H. Ayan. So, we have 2LA plus LB times 1,000 divided by 180. Note na si LA tsaka si LB ay in terms of meter. So, H, minimum H, 122.22, that is in terms of millimeter. Next equation, dito sa minimum H, you have 1,000 times Ln times 0.8 plus Fi over 1 with 1,500 divided by 36 plus N times the quantity LB all over LA. You remember that Ln is equal to the center to center long direction. So, that is equal to 124.56. And finally, the third condition is 100 mm. Pwede siyang mas less than 100 mm kapag malilit na slab siya. Let's say, 2.8 by 3 meters. If you will compute, maliit lang siya. Pero, the code says, hindi siya pwedeng lesser than 100 mm. Okay? So, sinali yan. 100 mm is 4 inches approximately. So, lumalabas na yung thickness natin na 125 is greater than the minimum. So, okay siya. Next is the effective depth. You have dx, dy, and d. Remember that dx is the effective depth of bottom bars, which is actually your bar number 4. Now, let's look at this longitudinal bars. Longitudinal bars yan yung parallel sa longer dimension, yung mahabang dimension, which is bars number 2, 4, and 6. Yung bars 2 and 6, yan yung bars na bumubuhat ng negative moments. Tapos yung bar number 4, yan yung nasa gitna. Yan yung bar na bumubuhat sa positive moment. Okay? So, remember na si bar number 4, yung bottom bar, yan ay unang inilatag. Okay? So, ang kanyang effective depth is equal to T minus cleared cover minus diameter of bar all over 2, which is equal to 99. Next, yung dy naman, yan yung bar number 3, which is bottom bars ng transverse bars, minus ka lang ng isang bar dito sa dx. So, 99 minus 12 will give you 87. Tapos yung d naman, yan yung effective depth ng mga bars na nasa gilid-gilid. So, bars 1, 2, 5, and 6, ang effective niyan ay 99, which is equal to thickness minus clear cover minus dB all over 2. Next is pag-compute naman ng superimposed dead loads. Yan yung mga binubuhat ng slab. Okay, ang binubuhat ng mga ng slab, yan yung live load, movable partition, floor finished, and ceiling utilities. Okay, superimposed dead loads, that is 1 plus 1.8 plus 0.4, will give you 3.2. Next, you have the live load na 4.8. Tapos dito naman, kailangan din nating unang computein yung maximum spacing ng main bars. In here, you have 3 conditions. Nandito siya. Sa main bars, you have 3 equations. 450 pi dv square all over 4 rho g times t, tsaka twice of thickness. So, you have 450, yung pi dv square all over 4 rho gt, that is 452, and finally, twice of thickness will give you 250. So, minimum dyan, you have 250. And then, for temperature and shrinkage bars, you have 3 conditions again. 450, 5 times h. Yung 5h, that is simply 5t. h is equal to t. So, 5 times 125 will give you 625. And finally, pi dt square all over 4 rho gt. So, 314.16. So, equivalent to 310. Meaning, yung minimum ng tatlong yan, 314.16, i-round down mo yan by 10 mm increments. So, 314 will give you 310. If in case this becomes 318 point something, i-round down mo yan by 10 increment, it will still give you 310. Next, your dead load is composed of the self-weight plus superimposed dead load. Dead load is simply unit weight of concrete times the thickness plus your superimposed dead load, so 6.15. Note na wag mo nang i-store ito sa calculator mo kasi exactly 2 decimal place. And then for W sub U, so that is 1.2 dead load plus 1.6 live load. That will give you 15.06. Again, you don't need to store this to your calculator because it is only 2 decimal places. And then finally, we have M, that is the short to long unsupported ratio. That is 21 all over 23 para hindi mo na siya i-store sa calculator in case. Or that is simply 0.913. Next, you have M1, M, and M2. If you will round down 0.913 by 0.05, this will give you 0.9. Yan yung lower boundary niya. Tapos, yung upper boundary ng M is 0.95. Ang next sa 0.913 by 0.05 increment is 0.95. Okay, so remember these 2 numbers. Magagamit natin ito sa pag-compute ng coefficients. Sa negative moments at continuous edges, ito na yan. So, ang ibig sabihin ng negative moments, yan yung may moment diagram na parang nakasimangot, ano? Tapos, kapag sinabing positive moment, yan yung may moment diagram na nakati. Parang sa continuous beam, di ba? Kapag sa gitna, positive moment, nakangiti. Kapag sa supports, negative moment, yung curve going down. So, ang bars na negative moments, you have bars 1, tsaka 2, tapos bars 6 and 5. Note na yung bars 1 and 2, yan ay nasa continuous edge. Meaning, merong katuloy na slab dito. Yung bar number 2 naman, meron din katuloy na slab. Yung bars number 5 and 6, nagte-terminate na yan dito sa beam. Meaning, wala nang slab dito sa kabila. Okay, so you have number 1 here, you also have number 2 there. Ang ibig sabihin yan, ito, number 1, tsaka bar number 2. So, yung pattern sa bars 1 and 2, parehas lang. First thing is to determine your coefficients, CA, tsaka CB sa bar number 2. And then, you analyze this as a singly reinforced beam with a beam width equal to 1 meter or unit width, no? 1,000 millimeter. So, moment is equal to C times W times L squared. Ganon din dito, C times W times L squared. Parang sa beam, meron tayong 1/8 times W times L squared. Yun din ang similarity dito. Only is that yung 1/8 dito nagiging C na siya. Okay, balik tayo sa interpolation. Yung kanina, in-explain natin paano nakuha yung lower bound tsaka yung upper boundary na 0.9 and 0.95. Tapos, from table 1. Remember na our slab is case 4 with 0.913 as your M. So, dito sa table 1, nandito siya. And 0.9 tsaka 0.95. So, yan ang i-interpolate natin. Okay? So, 0.9, you have 0.06. And then 0.95, you have 0.055. Ipasok mo yan sa yung calculator, you do interpolation, and you will get 0.0587. You store this to letter A. Next is, you multiply that with W sub U, which is 15.06 times LA squared. LA is 5.25 squared. It will give you 24.364. Next, you multiply this immediately by 1 million divided by 0.9 times 1,000 times D squared. Yung D squared, take note, that is walang subscript. Ito siya, 99 mm. And you will get 2.76. I suggest you store this to letter C. Okay? So, hindi ko na nilagyan dito ng storage kasi pwede namang idiretso na. That is if you are careful with your calculator. Okay? Next, we will now proceed to singly reinforced beam, yung kanyang mga procedures. So, meron tayong required draw. Yan ang equation. You will get 0.01323. You store this to letter B of your calculator. And, yung value na yan, you compare that with your raw minimum, which is equal to 0.006. Notice na yung required raw is greater than raw minimum, kaya okay siya. Now, yung 0.01323, that will also be your raw 1. So, raw 1 simply means na ito yung ating gagamitin para sa bar number 1. Next, we will now compute the required spacing of your 12 mm rebar. The equation here is, the equation for required S is pi dB square all over 4 rho D. Ito siya. Likewise, nandito rin yung mga equations ng MU. Okay, MU, tsaka yung RU. Ayan. RU is equal to MU all over phi dB square, wherein your phi is 0.9. D is always 1,000 millimeter. Okay, going back here, your required S is 86.33. You always round down by 10 millimeter increments. So this becomes 80 mm. So this is now your S1. Okay, so use a spacing of 80 millimeter, or this is your S1. Again, naglagay ako ng subscript dito na 1. Ang ibig sabihin ng S1, yan yung spacing ng bar number 1. Now, same procedure sa bar number 2. You have interpolation again. Going back to table 2. Dito na tayo. So, negative moments, long direction. Take note, yan ay long direction. Or that is CB. Again, we have case 4, tsaka 0.9 and 0.95. So, 0.04 tsaka 0.045 ang ating gagamitin. By interpolation, this becomes now 0.0413. Again, you store this to letter A. Then you immediately multiply it by W sub U and LB squared. So you now have 20.566. Multiply that by 1 million divided by 0.9 BD squared. You have 2.33. Tapos, you go back to this equation again. Your required draw is 0.010999. Store that to B. This time, you compare that again to raw minimum. So, greater siya, kaya okay. Also, this is now your raw 2. Tapos, yung required S, 103.87. Again, you round down, this becomes now 100 mm. Or this is now your S sub 2 para sa bar number